In this series of videos, we are going to be talking about inheritance. Inheritance is what we use to allow a class to extend an existing class. What happens in inheritance is that a class can inherit the members, and when we say members, we're talking about the fields and the methods of the class that it inherits from, or the class that it extends. We do that so we can create a specialized class from a parent class. So we have a general class and a specialized class. But it also helps us generalize common members of many classes into a new class. When an object is a specialized version of another object, we say that there is a relationship between those. This allows us to extend the capabilities of class by creating another specialized version of it. Using the term is a for the relationship implies that the specialized object has all the characteristics of the generalized object. For instance, we're going to write a vehicle class, and we're going to write a car class. So a vehicle is a general class, and a car class inherits all the features from the vehicle class. Likewise, we're going to have a truck class that will inherit all the general things from the vehicle class. Okay. And each specialized object will have additional characteristics that make it special. So there's a lot of terminology I'm using here. And we should probably discuss a little bit. But when we're talking about inheritance, inheritance involves a base class and a derived class, but there's other terminology that's used a lot. So we can talk about a base class and a derived class, or sometimes we speak of them as the generalized class and the specialized class, but they're both the same thing. Sometimes we refer to them as a parent class and the child class. And that terminology is often used because of the idea of inheritance. If you think about genetics, children inherit certain features from their parents. And then also sometimes we use the term superclass and subclass. And these different terminologies get used and interchanged a lot. So it's useful to understand that they're all basically describing the same thing in different terms. So for example, here, I'm saying a child class inherits the fields, properties, and methods from the parent class without any of them having to be rewritten. Okay, great. But I could also say that as the derived class inherits fields, properties, and methods from the base class, which means the exact same thing. We're using that so we don't have to repeat code. We can also add new fields, properties, and methods to the derived class to make it special. And the way we do this, the way we define in our code that inheritance is happening, is that when we declare a class, so here's our vehicle class for the upcoming demo we're going to be doing. I have a class vehicle, and inside that class I have its members, I have its fields, and I have its methods. When I create my car class, I can say class car, and then I use the keyword extends, and then I have automobile here, that should be vehicle. So I have a mistake in my slide. So car is going to extend the vehicle class. Okay. Car is the derived class, vehicle is the base class. Or we can think of vehicle as the parent class, car as the child class. So here is a UML diagram of the classes that we're going to build. So this is a UML diagram of the vehicle class, and the vehicle class has three fields. It has a make, that's a string, and notice the dash there, the minus sign, means this is a private field. Okay, we have model, which is a string, so we have the make and model of our vehicle, and we're also going to keep track of the mileage on our vehicle, and that's an int. Down here we have some public methods. They have the plus signs in front of them. We have the get make, which is a string, and the set make, which is a string, the get model and the set model. So we have getters and setters for each of our fields. There's get mileage and set mileage. And then we have an additional method called accelerate, because a vehicle can accelerate when you step on the gas. And then we have a toString. We're going to define the toString. We're going to override the toString from the object class. Then we're going to have another class called car. And the car is going to extend the vehicle class. So car, using this notation, will have make, model, mileage, get make, get model, the mileage, accelerate, and toString. But it will also have another field for the number of doors on the car. Is it a 2-door or a 4-door? So we can specify the number of doors as an int, and because we're doing another field in the car class, we're going to provide a getter and setter for the car. In the truck class, it's going to have all the same characteristics of a vehicle, but it's also going to have a couple fields that keep track whether it's a 4-wheel drive and whether it's a diesel truck. And because we have these two fields, we'll define is 4-wheel and set 4-wheel, and is diesel and set diesel for managing those two private fields. And we should have negative signs showing those are private. So my slides aren't perfect, but you get the idea. All right, in the next video, I'm actually going to create those 3 classes, and we're going to go through the process of inheritance.